before. Okay. So important, the strength of ammonia and amines as bases depends on the availability of the lone pair of electrons. I have said earlier, right? On nitrogen atom to bond with hydrogen atom. So ethylamine is the strongest base, ammonia, and phenylamine weakest base. So phenylamine, why phenylamine is weakest? What is phenylamine? বুদ্ধি একটা করলাম। This is phenyl ring, C6H5, anamine. ঠিক আছে, phenylamine. And ethylamine we know, right? C2H5 and H2, right? C2H5 and H2, ethylamine. আর মাঝখানে হচ্ছে ammonia. So ethylamine is strongest and phenylamine is weakest. তাহলে how you can easily explain now. Let us consider ammonia, ethylamine, and phenylamine as examples. We find that the strongest base of these three, ethylamine followed by ammonia, and finally phenylamine is weakest. Why? Ethylamine is strongest base because then ammonia, because ethyl group is electron donating, so it has a positive inductive effect. We know, right? Positive inductive effect means it has good electron donating capacity, right? That is positive inductive effect. By releasing electrons to nitrogen atom, the ethyl group makes the lone pair more readily available to bond with hydrogen ion than in ammonia, right? Ammonia just has 3 hydrogen atoms bonded to nitrogen, no alkyl groups present, so no positive inductive effect from ammonia. However, ammonia is stronger than phenylamine. Why? Because the lone pair of nitrogen is more readily, the lone pair of nitrogen will be delocalized inside the pi electron cloud, right? Inside the pi electron cloud. Thereby, the lone pair on nitrogen is less available for to accept the proton. Okay? So phenylamine to be delocalized into the benzene. This makes the lone pair less available to form dative covalent bond with hydrogen than in ammonia. So ethylamine is strongest and phenylamine is weakest. Very, very important questions. এগুলা হচ্ছে important কোনো question নাই, এগুলা দিতেই থাকবে দেখবা। Any question from here? This causes the lone pair of the nitrogen atom, which is same oxygen, nitrogen, chlorine, same ঘটনা হইতেছে সব জায়গায়। Oxygen, if it is phenol, then the lone pair of nitrogen is delocalized in the pi electron cloud inside the benzene ring, sinks into the benzene ring. Or if it is chlorine, then still we have lone pair electron, which is synced into the benzene ring, so becoming the delocalized pi electron system. Nitrogen has lone pair; it is basically sinking into the benzene ring and becoming the delocalized pi electron cloud. If the lone pair is not available on nitrogen, how come hydrogen ion will come and join there? Ulta na, mane ethylamine, your C2H5 group is electron donating, positive inductive effect. So it is donating electron towards nitrogen, right? Making nitrogen lone pair more available for protonic, so that accept protonic attack na, so that proton can be accepted, right? এখানে তো ঠিক উল্টা হইতেছে, nitrogen lone pair of nitrogen is less readily available, so making it more difficult for hydrogen ion to join and forming dative covalent bond. Do you understand? So easier it is to accept the hydrogen ion, more basic it will be. So ethylamine is the most basic one, then ammonia, then the last one is phenyl. Okay, fine. So এটা হচ্ছে in between alkylamine, ammonia and phenylamine. Relationship টা দেখা, alkylamine, ammonia, phenylamine. এরপর আমরা যেটা যাব primary, secondary, tertiary amine, that we can compare as well. Tertiary amines are most basic, right? Because we have more positive inductive effect from 3 alkyl groups. Very good. Very good. Question 1 এগুলো করবা formation of amine তাহলে we know halogen-alkane and ammonia it reacts and this ammonia is not aqueous কিন্তু it's alcoholic. This reaction we have studied in AS level. If halogen-alkanes react with ammonia, alcoholic ammonia মানে ethanolic ammonia, no trace of water can be present. That is a problem. If trace of water present, then it's a problem, right? So how bromoethane undergoes nucleophilic substitution reaction with ammonia to form a mixture of amine. In order to prepare ethylamine while avoiding the formation of secondary tertiary amine, we use excess hot ethanolic ammonia under pressure. এগুলো কিন্তু important. Excess hot. Excess, we need to give excess and we need to give hot ethanolic ammonia, right? So while avoiding formation of secondary and tertiary amine, see, if you don't give hot excess ammonia, then what will happen? Basically, this ethylamine, will further react with, say, see, ammonia is a base, but ethylamine, it is also a base, even a better base, right? So this base will again react with the halogen-alkane to form C, secondary amine. Is it clear? Why we are giving excess ammonia in order to form primary amine? See, why we are giving excess ammonia? Because if ammonia is excess, ethylamine cannot encompass the concentration of ammonia. Thereby, always ammonia will react with it. বোঝা যায় আমার কথাটা? If you give excess ammonia, then your product ethylamine will not get the chance to react with bromoalkane. That's why we are giving excess ammonia so that it reacts, right? If you give in less amount, so secondary and tertiary amine will form with the halogen again. Primary amine will react with them again in ethanol heated in a cell tube under pressure, but not in excess. We are not giving ammonia in excess, so that is the only difference, right? So in that case, ethylamine will take the lead, and it is more basic, right? The lone pair is more available. So since it's a nucleophilic substitution reaction, which one is the nucleophile? This one is the nucleophile. Here ammonia is the nucleophile, but definitely ethylamine is a better nucleophile because the lone pair is more readily available due to the positive inductive effect. Is it clear? Right? So secondary amine, then again tertiary amine, say, see this secondary amine is more basic, so it can form tertiary amine even. Formed in the name diethylamine, fine, but it can form tertiary amine even, right? So it can again react with this amine, so forming what? So if this CH3 I mean to লিখে দেই, এটা লিখে নাও if required, CH3 CH2 2, right? NH. If it reacts with again alkylamine মানে methylamine, CH3 CH2 NH2, then what forms? এটা একটু লিখে নাও, CH3, এই দেখো CH3 CH2 group, how many we have now? 3, N, right? Plus HBr. কি লিখলাম? এটা তো Br. Halogen alkane's সাথে it will react Br, so HBr, right? Even this can react further. এটা 4 degree মানে quaternary ammonium ion liver, CH3 CH2 2, CH3 CH2 এটা হচ্ছে 4 nitrogen, এটা positively charged, right? মানে অ্যামোনিয়াম আয়নের মতো অ্যামোনিয়াম আয়নে we have 4 hydrogen atom, now we have 4 ethyl groups, we have 4 ethyl groups, that's it. Ammonium ion. Yes, come in. Clear, clear. লিখছো? তাহলে if reacts with halogen alkane, amine, they can give you মানে halogen alkane can react with ammonia to form primary amine, secondary amine, tertiary amine, then quaternary ammonium compound. Quarter সিলেবাসে থাকা দরকার নেই, ট্রাই টু আন্ডারস্ট্যান্ড দ্য স্টাফ হোয়াট ইজ হ্যাপেনিং। ওরা কিন্তু টুইস্ট করবে, আমি তোমাকে বলি, মানে ইট ইজ ইয়োর ন্যাচারাল আন্ডারস্ট্যান্ডিং যে হ্যাঁ প্রাইমারি হয়েছে, এরপরে সেকেন্ডারি হবে, এরপর টার্সিয়ারি হবে, এবং কোয়াটারনারি হবে, রাইট? কোয়াটারনারি স্পেলিং ঠিক আছে? কোয়াটারনারি পারো তো? কোয়াটারনারি এরকম নাকি স্পেলিংটা? দেখো তো, দেখে নিও। হ্যাঁ, কোয়াটারনারি or quaternary ammonium compound, এটা একটু দেখে নিও। ওইটা এই যে চ্যাপ্টার 16 এ পাবা, ওই যে এখানে লিখে দিছে না চ্যাপ্টার 16, ওইখানে ওইটা লেখা আছে, দেখো। আচ্ছা, নাম্বার 2 তে যাই, এটা একটু শেষ করে দিই, একটু দাঁড়াও, একটু ওয়েট করো, এটা একটু শেষ করে দিই। হ্যাঁ, ক্লাস আছে? হ্যাঁ হ্যাঁ, 3 চট করে শেষ করে দিব, এগুলো সব আগে করে ফেলছো অলরেডি, এগুলো নতুন কিছু না। এই দেখো, potassium cyanide, right? A solution of potassium cyanide if you give, then halogen alkane reacts with cyanide. এই দেখো cyanide এখানে lone pair electron আছে, this will attack carbon forming ether nitride. So দেখো carbon number increases by 1, এটা অলরেডি পড়ে ফেলছো। হ্যাঁ, হিট এন্ড রিপ্লাই। হ্যাঁ জি। So again nucleophilic substitution, right? Nucleophilic substitution. আর এইটা এই যে তোমার এই নাইট্রাইল ফর্ম করার পর if you reduce it using lithium aluminum hydride, দেখছো, in dry ether, if you reduce it, you will get amine. So how to prepare amine, that is basically the discussion. And then ethanamide, amine, ethanamide, if we do reaction, if you reduce it with lithium aluminum hydride in dry ether, দেখছো কথাটা? 95% কেসে তোমার লিথিয়াম অ্যালুমিনিয়াম হাইড্রাইড ইন ড্রাই ইথার রিডাকশন আসলে এটা লেখা দিবা, you will get the marks. Ethylamine will form. So how to prepare ethylamine? Preparing phenylamine will start in the next class. Thank you for today. Assalamu alaikum.
ওয়ালাইকুম আসসালাম স্যার।
ভালো করে পড়ে ফেলো, হ্যাঁ, এগুলা সব রাইখো না কিছু।